Hi everyone, my name is USENIX from National University of Singapore. I'm very happy to present our KnowPhish work, which focuses on enhancing reference-based phishing detection using LLM and multimodal knowledge graphs. So to begin with, what is phishing? As you can see from these two figures, it is very easy to tell the right-hand side one is likely to be a phishing website, because it shows the brand intention of PayPal through logo, but it does not use the legitimate domain of PayPal. Moreover, it requires credentials from users. These evidence make it a suspicious website. And in recent years, there are a large number of financial losses due to phishing campaigns, and that's why we need to develop effective and efficient phishing detectors. In recent research, there is a type of methods called reference-based phishing detector. They are regarded as the state-of-the-art phishing detectors because of its generalizability and explainability. They leverage computer vision models to analyze the brand intention from logos, and once the brand intention is identified, we compare the domain with the legitimate domains. Let's say if it passes the domain check, it will classify it as a benign website. Otherwise, it will classify it as phishing. However, we do find that there are several limitations from existing work. The first one is we call limited scale brand knowledge. The existing solution only maintains the brand knowledge of 277 brands, but phishing attacks are diverse, which can target thousands of brands. 277 is definitely not sufficient. And take these two examples here. It is hard to tell whether they are phishing or not without concrete brand knowledge. This actually highlights the need to have a much better coverage of potential phishing targets. The second challenge we pinpoint is the logoless phishing webpage. This phishing webpage does not show their brand intention through logos. Instead, they reveal it in the HTML. Existing work like Phishpedia and Phish Intention, they cannot handle such cases because they only analyze logos. This also highlights the need for the phishing detectors capable of text or HTML analysis. Our solution to the first challenge is to construct a large-scale brand knowledge base. It covers more than 20,000 potential phishing targets, and it also provides rich multimodal brand knowledge, such as logos, domains, and aliases. However, constructing a large-scale brand knowledge base is a non-trivial task. There are millions of brands in the world. Collecting all of them is time-consuming and unrealistic. So that leads to a question: what indicates a potential phishing target? And we conducted empirical analysis using two datasets from different sources and periods to answer this question. In our first observation, we find that the phishing targets changes significantly across different datasets. This aligns with the findings from previous research and proves that we cannot maintain a brand knowledge base based on any specific dataset. In our second question, we studied the industry of these phishing targets. We selected 10 high-value industries to categorize each phishing target in both datasets. And we find that these phishing targets consistently belongs to the 10 high-value industries. This shows that the industry of phishing targets remain time invariant. So going back to our original question, if a brand belongs to a high-risk industry, it is likely to be a phishing target. And the fact that the high-value industries usually indicates phishing targets can be viewed as a fact triplet in knowledge graphs. This can be a very helpful information for us to search for potential phishing targets. In this work, we instantiate these industries as Wikidata categories through the instance of relation. And eventually, we curated two lists of Wikidata categories. One is called narrow categories, which directly represent the high-value industries. And the other one is called general categories, which may not represent the high-value industries directly, but still, we can utilize it for augmenting the potential phishing target list. With the list of Wikidata categories available, we are able to construct KnowPhish, starting by a brand search to search for potential phishing targets, and then perform brand knowledge acquisition and augmentation of these targets. The first part of brand search is called category-based brand search, where we utilize the narrow categories we just curated and their subcategories. By searching brands through these categories in Wikidata, we are able to obtain a list of brands belonging to these high-risk industries, which is very likely to be phishing targets. We also introduce another brand search component called popularity-based brand search, because we find that the Wikidata information may be incomplete, thus missing a potential set of phishing targets. However, due to the fact that the general categories does not always represent high-risk targets, we add another condition to this search component, which is the domain popularity. Because the more popular a brand is, the more likely it will be a phishing target. These two search algorithms eventually lead to a comprehensive list of potential phishing targets worldwide. We would then construct brand knowledge based on the set of identified brands, which goes to the second part of our KnowPhish construction, knowledge acquisition and augmentation. As illustrated in the figure, we collect rich multimodal brand knowledge from the multiple high-quality sources. The brand knowledge is initialized from the information in Wikidata and then augmented through other high-quality data sources like the Tranco top domain list and the Google image search. The knowledge comprises the logo variants and the legitimate domains, and we also introduce the alias variants for the development of our text-based phishing detector. By now, the brand knowledge base has been fully constructed and can be equipped to any reference-based phishing detector to enhance their performance without any runtime maintenance cost. Our solution for the second challenge, which is the logoless phishing with textual brand intention, is to introduce further analysis of the text information of the web page, which is mainly the HTML. This actually makes our phishing detector operating in a multimodal way. We call this phishing detector as KnowPhish Detector. In short, if no logo can be found in the screenshot, we leverage a large language model to obtain the target brand of that web page. To identify the textual brand intention through the reference-based phishing detection framework, our text brand extractor performs two tasks. We first feed the HTML together with our well-crafted prompt into an LLM, and which outputs a predicted brand. And the predicted brand will go through an exact matching process with all the aliases in our KnowPhish knowledge base. For example, the predicted brand Australia Post matches an alias of the brand Australia Post in our knowledge base. So the brand intention of this web page is identified as Australia Post. Our text-based components also includes the analysis for credential requiring page, but due to time limit, I won't go through all the details. But the general idea is that by analyzing the HTML elements through language models, we are able to detect implicit credential requiring pages that previous computer vision-based approach cannot detect. These eventually help us alleviate the false negatives caused by the CRP classifier. Now we go to the empirical evaluation part. We have done extensive experiments to evaluate the performance of our phishing detector. This mainly includes a closed-word study and a field study under local context. The closed-word study dataset is collected by us, and it is a balanced dataset. Some interesting observation is that the KnowPhish knowledge base directly enhances different reference-based phishing detector to achieve higher recall, but with negligible or little impact on precision. And it also achieves much lower runtime than a recent baseline called DynaPhish. We also find that the KnowPhish covers more phishing targets than the other two baselines, which is the fundamental reason for the higher recall. If we take a closer look at the KnowPhish, as you can see, which is the work from last year, we find that it actually suffers from the so-called logo matching failure problem. KnowPhish improves it by providing a much more diverse brand knowledge base, like the logos, or analyzing the text information when the logo analysis fails. Thus, it has a higher chance to detect the brand intention than KnowPhish does. And in our field study, we evaluate the approaches through a real-world data set from Singapore governmental agency. So in addition to the fact that the KPD plus KnowPhish detects the greatest number of phishing web pages, it also identifies many local phishing targets in Singapore, like the Singapore Post, DBS Bank, and Shopee. This actually further validates our empirical insights that the high-value industries usually indicates phishing targets. Another interesting finding from our field study is that the logoless phishing web pages with textual brand intention are very common in real world, and image-based approaches cannot detect them. But our multimodal solution, KPD plus KnowPhish, is able to detect logoless phishing. Here comes our takeaway. So first, we propose KnowPhish, which is a large-scale multimodal brand knowledge base to instantly enhance any reference-based phishing detectors. We also propose KnowPhish Detector, KPD, to work in conjunction with our KnowPhish knowledge base. In this case, it can detect phishing web pages with or without logos. So that's all for my talk, and thank you very much. I'm willing to take your questions.